Hi there, my name is Thomas. I'm representing investmentexcel.com in this session today, where I will show you how to calculate covariance and the covariance matrix in particular. I will demonstrate the covariance matrix and the covariance with some US stocks, and will also calculate a portfolio of US stocks in terms of its standard deviation and in terms of its variance. This video and the underlying Excel workbook are both available on investmentexcel.com and spotafile.com. Alright, let's begin. I will start with the inputs, and when we calculate standard deviation and covariance and variance for use in finance, normally we use the returns, but the returns in relative numbers, that is in percentages. But in principle we could also do it in USD, in monetary terms. These figures here are randomly chosen, and they can be interpreted in this case as historical figures, so 5 days history. And the reason why I underline that they can be interpreted as historical and not as future expected returns is that there is a slight difference between how we calculate the standard deviation, which is the concept we use for future unknown returns, and the standard error, which is a term we use for historical and observed values. I will show you the difference later. But back to this input, let's call it matrix, of Microsoft, Google, Netflix, Apple and Amazon, the heavyweights. Before we work out the covariance matrix, we will calculate the correlation matrix, and it's calculated down here, as you might know, or otherwise I refer to another session I've made on correlations. The diagonal in the correlation matrix is by construction a list of nums of ones. So Microsoft's correlation with Microsoft itself is 1, likewise for the other stocks. This is a key feature for the correlation matrix. Another key feature is that the numbers on both sides, if you look at it from a symmetrical point of view, they are identical. So this value here, for instance, let's call it in cell number 1, 2, is the same as here in number 2, 1. So there's symmetry. So sometimes you will see a correlation matrix like this, fully filled. Other times you will see just the upper part or the lower part of the matrix. Sometimes you might even see a matrix without the ones because it's implicit. So this is one way of looking at it, and the other one, of course, if I mark all the other correlations. Okay, so how did I calculate it? In this case I use the Excel correl function, which is a correlation function, a pairwise correlation function. So you type in here the time series between Google and Microsoft, and if you type it in here, all byte turned around, it gives the same result. So correlation between Google and Microsoft is the same as the correlation between Microsoft and Google. If you have a large matrix of numbers, a large time series, you could use as well also the inbuilt function in Excel in data analysis. We have a correlation function here which you can easily use. Just inputting the data. Just make sure that you rank the columns orderly, so you have your assets from left to right, and you have the observations downwards. Now we need to build the standard deviation matrix, and the standard deviation matrix is pretty simple. It's the same format, same dimensions as the correlation matrix. So number of assets time number of assets, and you fill out with blanks or with zeros actually, and then on the diagonal you just calculate the standard deviation for each asset. And note here, this was what I was talking about, the small difference between the sample standard deviation and the population standard deviation. I use the STDVS, which is the sampled, which if we calculate it on future expected returns, we will use a P, and there's a slight difference in the denominator of the calculation due to a degrees of freedom in the estimation process of the sample. Anyway, now we have the basic building blocks for calculating the covariance matrix, and I have labeled the correlation matrix core. So I have filled out this, put in a name up here, core, and the same with this, STD. And the reason for doing that is to avoid too long a string up here, which can be rather complicated when you use all the mmult functionalities in Excel. But applying this formula, so you multiply first the correlation matrix, it has to be in the right order. First the standard deviation times the correlation matrix, multiply them, and then you multiply this matrix with the standard deviation matrix here. And having done that, will only leave you with a one value here, and sometimes it just says value. So what you have to do is to expand the matrix in order for Excel to calculate the entire matrix. You put up your mouse up here, or your pointer up here, so you see the marking, and then you type Control, Shift and Enter. And this is the way to activate in Excel the matrix multiplication or activation in general. So the Control, Shift, Enter function has to be typed at the same time. Normally I just start putting down Control function, then the Shift function, and then I hit Enter, because then I'm sure it's the right way for Excel. So now what have we calculated here? It is a covariance matrix. That means on the diagonal we have the variance. So that's one feature of the covariance matrix. The diagonal represents the individual asset variances. So this one on Microsoft I should be able to replicate, and I've done it here. The variance of Microsoft. Remember, the variance is calculated as the standard deviation squared. So I take the standard deviation of Microsoft, 0.44% squared, and you see, gives the same result, and the same all the way down. And then on the sides, again, just like the correlation matrix, we have a symmetrical pattern. So all the numbers in the northern part of the diagonal is exactly the same, just on the flip side, as they are down here. In other words, covariance between Microsoft and Google is the same as the covariance between Google and Microsoft. And the way to calculate one individual covariance is stated down here. So you take the standard deviation of the two respective stocks and multiply them, and then you multiply with the pairwise correlation. In this case, we see this result between Google and Microsoft, which is consistent with the result built in the matrix. Instead of doing all the matrix algebra, you could, again, just as with the correlation matrix, use the built-in functionality covariance, and you just, one more time, just mark all the returns in the right ranking. And perhaps I should note here that the data analysis doesn't come with Excel of itself. You have to make an add-in. You have to do the add-in of this functionality yourself in File, Options, Add-ins, and then you will find it down here. And if you don't find it, you have to download it. But it is in this tool pack and also this tool pack. So these have to be active. The covariance variance matrix is a structure governing the individual risk and the pairwise risk. So it's the total structure of the multivariate case. It could be from the population if we look forward, and it could be from the sample if we look as here at history. The dependent structure you will find here, and obviously if what we looked at was a set of random variables with independence, you will have 0 in all the correlation fields. For instance, if we wanted to throw free dice or free die, then there is no dependence, there's no correlation between the outcome of the first dice with the second and the third. So all would be 0, and then there would be a standard deviation on the first dice, on the second and the third dice, and it would be 0 here. But normally when we have financial assets, we have correlation between them. This one is used in portfolio analysis to calculate a portfolio's risk, and the only thing we need in order to calculate a portfolio's risk is to take into account the relative amount or the relative weighting between the assets in the portfolio. And here's a simple example with the 5 stocks and how much they weigh in a portfolio, summing to 100. And then I have to do some simple calculations again with the mult factor, and I will end up with a variance of a total portfolio, and I'll end up with a standard deviation on the total portfolio based on the multivariate structure here. And this is only the risk, there's no returns in here, so this is just the risk factor of the multivariate sample. Anyway, that was it. Thank you.